Welcome to the third part of Chapter 7, Lists and Tuples. In this part, we will cover processing lists, two-dimensional lists, and tuples. Processing lists can be used in many mathematical applications, not just for storing names or numbers or relevant, you can say, data. No, we can use them for data that makes sense. Things like maybe scores could be, or some ordinal data, or some data that can be used for mathematical applications, for any kind of maybe statistical application. And in that case, we can process the lists or whatever list of our interest based on that application. Just one common simple example. Imagine we have scores of students stored in a list, and we would like to get the average, maybe a standard deviation as a statistical indicator, or anything similar to that. We can apply this all the mathematical or whatever mathematical operation we need based on the process of the list, or the way we are processing the list of interest. We can calculate the total summation, this is possible, of the list. We can actually use the, you can say, the summing up by looping. We can loop from the beginning of the array until its end and accumulate all the numbers to get the total sum. This is possible. We can calculate the average. Could be of any other application in order for us to process the data in the proper way or in the way of interest. And we will see in practical we have different types of applications, mathematical application using lists. However, this is not only the case. If you remember, since we explained about files last chapter, we mentioned that files are used for long-term save of data, or a way of saving data for the long term. And in this case, we may be interested in transferring some data from lists to files. In order for us to do that, we can write all the data available in a list using write lines, and this will transfer all data from one list to a file. Automatically, you don't need to interfere, it's just one line in this case from the object of the list to the object of the file. However, the only problem with such a scenario or with such a method is the lack of \n after each line or after each element of the list. We will have all the elements stored together, connected, and in that case we may not have a nice representation of these elements. If you are interested in having elements separated, each on one line or each in a separate line, you need to use the for loop. So with the for loop, you can store line by line, and you don't have to write all lines together. You can write line at once for each and every element. If you want to retrieve data from a file that is stored as a list, you can use read lines, and that will take all the data stored in a file and bring it to you to a list. This is possible. You will have your elements back again. You can strip \n if it is available, if it is included, because we may intentionally include it just to keep our file readable or in a better readable way. And in that case, we can strip it for each and every element. And that's a possible way of processing files. And we will see in practical and tutorial how useful these processing methods are. Two-dimensional lists. What we have explained so far is actually one-dimensional list. It's just like a vector in physics or mathematics. One-dimensional. Either it is a row or a column. You can consider it a row or you can consider it a column. It's up to you. However, in many applications, one dimension is not enough. We may need to have another dimension for different representations of data. And this is possible, this is allowed in lists. We can grow our dimensional size of the list based on our application. So two-dimensional lists are possible and available in Python, and they are represented by a list of lists. Why? Let me show you graphically. Look at this. We have a list of two names here, which is row 0. So in row 0, we have a list. This is a list, consider just a list with two elements, and these two elements are actually composing two columns. Now if we go one step to row 1, we will have also two other columns, two same columns, sorry, but with two other elements. And if we move again one more step to row 2, we will have also the possibility of storing two other elements. That's why this is a list of one dimension, another list of one dimension, another list of one dimension. So we have a list of lists. These lists are represented by rows and columns. So this is the idea of two-dimensional list. And we usually process such a representation of lists by nested loops. Let me show you. I have an example. We have these indexes that tell us which element is which. So for the first element, we have I0 and J0. You can consider I as a row and J as a column. And it grows because the first row is considered index 0 for all row elements, and the column is changeable. For row 1, it is 1 for all row elements, and the column is changeable. And for row 2, it's 2 for all row elements, and the columns are changeable. Okay. In this case, we can create a loop like this. Let's say we have this kind of nums or numbers as a list: 1, 2, 3, first row, 4, 5, 6, second row, 7, 8, 9, third row. So we have 3 rows, 3 columns, 3 by 3 list. If we print it, it will be displayed the way it is, exactly. And now let's say we would like to display it the way we display our list in mathematics, or the usual representation of a list that we have in our, you can say, traditional math or physics. We can initialize an indicator, or actually a locator of index of the rows, and another one for columns, and we can loop from the first index to the last index for the rows, and from first index inside of the outer loop. Here we have an inner loop for the J, or for the columns of each row, and we loop 3 times from 0 to 2 inclusive. Why do we do that? If you remember, look at here, for 0, column 0, sorry, row 0, we change column 3 times, and the same goes to all other rows. So here we have the row changes from 0 to 1, 2, so 3 times, and each of these 0, 1, 2, we have a J indicator of the column that changes 3 times for each of those. And then we can display, this will display it for you row after another. That means 1, 2, 3, the next row, 4, 5, 6, the next row, 7, 8, 9. Tuples. We're done with lists. Now the second famous or common type of lists, sequences that we use in Python is actually tuples. The main difference between lists and tuples is actually tuples are immutable. That means we cannot change their elements once they are assigned or created. And in that case, we have, you can say, limitation of tuples that we cannot modify them, we cannot add to them, append, it's not possible. We cannot remove, we cannot insert, we cannot sort them, or we cannot reverse them. So these are the methods that we cannot apply to tuples. However, we can get index of an element. This is possible, similar to the list we just explained in previous session. We can get the length of the tuple, the minimum, the maximum, minimum element, or the maximum element, or whatever relevant to that. We can use in, not in, all other operators like similar applications of lists can be, you can say, possible or can be valid, or it is valid actually for tuples, except for the modification, removal, insertion, appending, reversing, sorting, anything that changes the items or changes the rhythm of the items or their contents. That's not possible. Now you may ask, what's the point? Why do we need to have tuples if it is actually representing for us the same facility or the same idea or the same concept or applications lists provide? What's the point? Why do we need to have tuples? Let me get to that, but before I go for that answer, I forgot to mention about the format. Similar to lists, we have the brackets of lists. Here we don't have brackets, rather we have parentheses. These parentheses represent the tuple, and once you create this tuple, you can't change its elements. It's just fixed. You have to decide from the beginning what you're going to have. So, I said earlier, what's the point? Why would we go for tuples? Actually, there are 2 or 3 main points of having tuples. The first one, tuples are considered much faster. And I'll just give you a little bit of a tip about why it is faster. Now think about lists of their dynamic feature, that we can grow their size or shrink their size, change the elements inside of them. Do we need to have any, you can say, additional applications or additional features or objects or memory to do so? Of course we need, and that's why processing of tuples doesn't require that much of memory or processing, and that's why it is faster. The second thing, in many computing applications or computational, you can say, algorithms and applications, we need to have our data protected, not to be changed. Tuple doesn't allow the change of elements. So if you are sure that your elements will not be changed and you don't want anyone to mess up with them, then in that case you can use tuples. And there are actually some operations in Python can be done only by tuples, require tuples. And for that specific reason, we have these tuples. We have 2 functions for lists. We explain about lists, this built-in function that we can use for just converting, you can say, a list of elements to a list. So it could be generated from range or any other relevant application or function, and we can create a list. We can also convert a tuple to a list using list itself. So you may say, okay, I have a tuple, I cannot change its elements. You can take a copy of it by using list and convert this tuple to a list. Then you can modify its elements. Let's say, okay, I modify these elements. Now, how can I use a tuple to keep the modified elements? I don't want anyone to mess up with them. I don't want anyone to change them. Well, you can use tuple as a function to convert that list to tuple again. So you can convert a list to a tuple using tuple as a function, or you can convert a tuple to a list using list function. However, the tuple itself that you have created, whatever it is, cannot be changed. You can take a copy of it and convert it to a list. You can change that copy, not the original tuple. And this is the end of our chapter. In this chapter we covered lists, the way we process them, their relevant operations and methods, you can say the built-in methods. We also spoke about the 2-dimensional lists and how we can process them using rows and columns. We also spoke about tuples, their advantages, limitations, and how we can convert between tuples and lists. I hope you guys enjoy this session, and this is the end of the chapter. Please wait for the tutorial very soon. Have a good time.